So I'm just gonna go ahead by starting answering question A. So with that being the case, I'm just gonna go ahead and read the question. So it said, if you start with 14 grams of magnesium and 12 grams of oxygen. So from this one, I'm just gonna go ahead and do the underlying things right here. Those are the two given information that I have. And now I'm determining, I'm supposed to determine the limiting reactants. And therefore, I will be able to determine which one is the access. Since we have two different reactants, so we're gonna have to identify which one is which. First, you can say that, okay, 2 moles of this and 1 mole of that, but that's not right. We have to use the mole to determine which one will be the smallest mole, and that one will be the limiting reactant after, of course, divide by the coefficients. So, start first, A. So I have 14.8 grams of magnesium. So this is what I do. I do the same thing too. I'm giving that information just 12 grams of oxygen gas. Remember that we're going to be looking at dividing by coefficients. So I'm going to go ahead and look at a coefficient right here. So magnesium is 2, so I'm just going to write out 2. Oh, by the way, you can't do that one just yet because first, for this equation, we don't have the mole. Therefore, we have to figure out what the mole is first by dividing the grams by molar mass. I'll give you a hint here. First, divide grams by molar mass. And these are the additional steps for this more advanced one, which is the one that you did do yesterday. So I'm gonna go ahead and look at the periodic table of the magnesium. That would give me about 24.306. 4.306 grams of magnesium per 1 mole, because that's the unit of magnesium. Therefore, we can cancel this one out. Now I have only the mole of magnesium. So when I have the mole of magnesium, I'm gonna have to divide by the coefficients. So same thing right here. So go ahead, do 2 steps. So go ahead and give me the answer first by plugging in number. 14.8 divided by, 14.8 multiplied by 1 divided by 24.306, and that would give me the answer of 605, and that should give me more of magnesium. And then I will use, now I'm going to multiply by 1 mole of magnesium too, and I'm using coefficient, which is 2, so I'm going to write out in yellow. Magnesium, that should give me the number of that half. So I have that 0.302 mole of magnesium. That's the first thing you do for the first one. And now you repeat the same process, which first look at the oxygen. Since oxygen is oxygen 2, and from looking at atomic mass, which is 15.999 times 2, and that should give me about 31.998 grams of oxygen 2. That's very important that you write it out. Mole of oxygen 2. That's very important because now if you went into 1, oxygen is 2. Because normally for oxygen gas, it is di-molecule, which is this. Now give me the answer. So divided the grams given by the molar mass of the dimolecule, and that should give me about 0.375 mole of oxygen. Now you using the mole ratio, which is 1. No number obviously is 1. Go ahead and cancel this one out. You do the same in there. So the only unit I have is to multiply by 1, and that should result in the same number. 0.375 mole of oxygen 2. So now we have 2 different numbers, so we're going to determine which one is the limiting, which one is excess by go back to our theory here. Limiting reactant will be the smallest number of mole after dividing by coefficient, which is what we did over there. And the excess one would be the one that has a greater amount of mole after divided by coefficient. Of course, we divide by the coefficient in order for us to get the number of mole by 1 mole of each one of them. Since you have 2 mole here, that's why we have to divide by 2. And since you had 1 here, that's why we divide by 1. Now we compare between those 2 numbers, and I'm gonna go ahead and determine. So between these 2 numbers, which one is the smallest one? Smaller. You should know by now. So I'm just gonna say that this is smaller. So I'm just gonna say limiting. Okay, and this one is greater, which is excess. Because you're gonna be using these 2 numbers for the next part, which is to answer. Okay, so the first one, we've already determined the answer. So go back to question B, determine the number of mole of products magnesium oxide produced. So with that being the case, we're gonna go ahead and have to start with always will. Start with the limiting thing. So I'm just gonna go ahead and when I be here, I'm starting with 0.3202 mole of magnesium, and that's the limiting one. That's why I have it in that color. So now we're going to use the mole ratio. So always, this is what you're looking for. So you're looking for determine the mole of magnesium produced. That is what you're looking for. So you would write that down, mole here. It doesn't matter what it is, so as long as that's what you're looking for, that's what you will put right here. And over here, you will start with the mole of the limiting one, which is magnesium. So now you cancel the limiting one, and that should give you the number of mole of the product, or what you're looking for in this case. So I'm just gonna go ahead and write down the number for the magnesium oxide, which is coded this number. And mole of magnesium, which is 2. So on your calculator, it is this number 0.302 multiplied by the fraction. And you should give me the number of, and that will be half of that. 0.302 half. 0.151 mole of magnesium oxide produced. So if the question is looking for mole of magnesium oxide produced, you will stop there. That would be one-step process. But if the question is asking you to determine the grams of magnesium oxide produced or the grams of some other product. So in this case, I already have 1 product, but for your test, you're going to have multiple products. So you will always start with that one again, 0.151 mole of magnesium oxide. You need to be able to get from mole to grams. There's nothing right here. Mole to grams. So we multiply by molar mass. If you forgot mole to grams, you always multiply by molar mass. And molar mass is already grams per mole. magnesium oxide, because that's what we're looking for. When you cancel the unit out, you see how I cancel that one out. And now we're gonna go ahead and look at the periodic table to see where magnesium is. Atomic mass is 24.305 plus the molar mass of oxygen, and that would give me about 40.304. Now you do the math, so that would be the number of mole, which is 0.151 times 40.304, and that should actually give me the number of mole, which is 6.09 grams of magnesium oxide. So now we've determined A and B and already C. Now the last one to determine the axis. So B, determine axis first. So our axis is, this is your axis. So therefore I should be writing that in green. But we always start with the limiting one, so I'm just gonna go ahead and use this color. We always start with what we have. That's not the color I need. 3, 2 moles of magnesium. Multiply by, now I'm gonna use the mole ratio first because they're looking for grams, so I'm converting from mole to grams. So I'm gonna write down mole of my limiting, which is this one, and the other one I'm looking for, which is the axis one. So you can't really say this is the axis since this is limiting, so the other one should be axis. Okay, let's double check. Yes, that's what it is. So that would be mole of oxygen. Even though it doesn't say mole of oxygen, it says axis. You should be able to determine which of these are axis and which of these are limiting. Now you go with the number you see. 1 there, 2 here, and then when you start canceling the unit out, you still have the number, which is 0.302 times the fraction. Let's give me the number. 0.3. That should give me this answer right here. 0.151 mole of oxygen. Now we're going to have to determine from mole to grams, since the question is asking for grams. So we start with this real quick. Mole of oxygen. We multiply by the molar mass, which is the one over here, 31.998. Divide by 1 mole of oxygen, grams of oxygen, and then you do the math times 31.998, and that should give me about 4.83 grams. This is, remember, this is used, this is not what's left. So in order for you to determine what's left, you're gonna have to left, right? It's gonna have, you start with how many? 12 grams. You minus what's being used, which is 4.83, and that should give you the answer of what's left. 7.17 grams left. And that's how you solve the problem. See, it is time consuming since they're more advanced, they require more skills, so you're gonna have to take time doing this problem.